GauessUp TableTorch is an add-on for Google Sheets. Let's explore its linear regression function. Each point on this chart represents some used vehicle's price and depreciated maximum power. These two variables have a Pearson correlation coefficient of 0.86. It's not hard to model the dependency of price on power by drawing a straight line like this. The formula for this line would also be a simple multiplication of the engine's power by a coefficient plus an additional constant, usually called bias or intercept. This method of modeling is called linear regression. Let's define a dependent variable y to be equal to a sum of factors x multiplied by their respective coefficients, denoted here as betas, plus the residual epsilon, sometimes also called error. If we look at the x and beta as vectors, it can also be represented in a simpler form. Linear regression applies an algorithm, such as the ordinary least squares, that attempts to estimate such coefficients beta for the given dataset of records x, that the residual epsilon comes down as close as possible to 0. The resulting linear model can then be used to predict the values of a dependent variable y. The TableTorch add-on allows you to perform linear regressions right inside your spreadsheet. Furthermore, it also provides you with quite useful options that are considered to be standard industry practice. Let's use a vehicle's prices dataset as an example. Each vehicle is characterized by a number of features such as its engine's power and volume, its model, whether it has an automatic gearbox, and so on. With TableTorch, we can build a linear model to predict the selling price of a vehicle based on its features. The dataset is split into two sheets, each containing 1,000 rows. We'll fit a model on the training sheet and then assess the model's performance on a test sheet. Let's launch TableTorch by clicking on its icon on the right side panel of Google Sheets. Use the link to TableTorch's setup instructions in the video's description. Select a range containing both the dependent variable, which is the selling price in our case, and the independent variables or features. Click the Linear Regression button. TableTorch will analyze the data to exclude non-numeric columns, as well as to provide you with a list of features to include into a regression, and a drop-down selector of label, which is the variable to model. Let's uncheck the columns that shall not be used as features in a regression. Click the Fit Model button to proceed. It might take some time, since TableTorch will need to iterate over the dataset up to 100 times in order for the coefficients to converge to an optimum. TableTorch has succeeded in producing a model. It shows model quality metrics right away, such as the R-squared, or the fraction of explained variance, and the root mean squared error. You can also click the Add Summary Sheet button to produce a separate sheet describing the model in greater detail. A color scheme is applied to the coefficients to make it easier to find the most significant features. TableTorch applies standard scaling by default, and hence the summary sheet also shows the mean value and standard deviation for each feature. If it's not necessary, you can disable standard scaling in Learning Options before fitting a model. Back on the Learning Summary pane, you can find an Insert Prediction Column button. Click it to add a column with the formula that applies the model on the present features. This formula is usable right away on the new data. We can also use it to calculate a relative error for particular rows. Let's now copy the formula to our test vehicles dataset. A relative error column will help us identify the accuracy of our model. Let's sort the rows by the relative error in an ascending order. Here we can see that the median relative error is about 20%, which is probably not bad for a first try. However, if we take a look at the linear regression menu again, we will see many settings that could help the regression produce a better model. TableTorch uses reasonable defaults for the learning options. Nevertheless, sometimes it makes sense to experiment with them. There are also such sampling options as the k-fold cross-validation, either proportional or uniform stratified random sampling, as well as the sampling with replacement. Application of these methods is considered to be a standard industry practice for producing models that are resilient against the new data. Follow a link in the video's description to the Fine-Tuning Regressions article to learn more about these options as well as some featured engineering techniques. Thank you for using or considering using TableTorch. Please feel free to put down your thoughts in the comments below or contact us via tt.support@gaoasoft.com.